Hello everyone, and welcome to this lightning talk on the design and deployment of event-based file processing in a gateway. I'll begin with a brief description of some of the general motivation and the specific needs for file processing in our specific gateway, and why event-based processing is an appropriate solution for us. I'll then describe the design and deployment of our extensible, portable, and scalable file processing pipeline. I then conclude with some lessons that we learned over the course of our deployment and how our technology choices each play a part in making our deployment extensible, portable, and scalable. In general, gateways may want to process data files uploaded by their users for several reasons. First, such processing, particularly with respect to metadata extraction, is often required in order to enable future data search and discovery on the resources managed by the gateway. In some instances, domain-specific processing is also required. For example, in the case of geospatial files, users may often want to validate the data that they have uploaded, and in these cases, some domain-specific processing may be necessary to register and create map layers out of the files that have been uploaded. File processing may also be necessary to either ingest these uploaded files into some internal standardized representation or database, or to prepare them for use with other gateway tools. Event-based processing is particularly desirable for several reasons. First, in cases where automated processing of these files is required, rather than performing them in response to specific user requests, events can help in automating some of this processing. Second, event-based processing also enables scalability because the gateway that's generating these events can be separated from the event handlers and the file processors that are operating on these events. And finally, various gateway components that deal with files only need to generate the appropriate events and then can be assured that uniform processing on these events occurs irrespective of the component that was generating the original event. In the specific case of our gateway called MyGeoHub, which is based on the Hub0 Gateway framework and provides various capabilities for geospatial research, file processing is often required to, one, extract metadata from geospatial files to support subsequent search, but to also prepare them for visual preview. However, Hub0 provides various options for file management, and the two most common are the web-based content management system, or the CMS, and containerized tools. Thus, we required a solution for file processing that would be agnostic to the source of these geospatial files, either the CMS or the containerized tools. Here is the system design of our solution. So a solution utilizes the RabbitMQ message broker to pass file events from the gateway to the message processing worker containers, which perform the necessary file processing operations, and this involves both the metadata extraction and the geospatial preview as I just described. File events from the tool sessions are generated by kernel level monitoring via auditd. We chose to use Logstash to ingest these messages generated by auditd and pass them along to RabbitMQ due to its diverse set of input and output plugins, which can be used to both ingest messages from auditd but then also send messages out to RabbitMQ. The CMS independently generates and sends AMQP messages directly to RabbitMQ when the user manipulates files on the CMS web interface. RabbitMQ, the QGIS map server, and the worker containers are all orchestrated using Kubernetes on the Jetstream Academic Cloud. We use Ingress resources and an Ingress load balancer to enable the MyGeoHub gateway to communicate with RabbitMQ and the QGIS map server via fully qualified domain names rather than use specific IP numbers or port numbers. These various technology choices provided us with several advantages that we discovered over the course of our deployment. I'll conclude here with 4 such lessons that we've learned during this deployment. First, our use of Logstash allows us to filter the firehose of messages that auditd produces, but also simplify and augment them if necessary before passing them along to RabbitMQ. And as part of the simplification, we are also able to standardize and rename fields so that they match with the messages that are sent from the CMS. Our use of Kubernetes and specifically Ingress resources allows us to use wildcard certificates and path rewrites to expose multiple services via the same domain name and separate paths. So for instance, here we have the same domain name, pipeline.geoedf.org, but then separate paths to point to the QGIS map server and the RabbitMQ administration interface. In addition to Kubernetes, we also use Helm to manage our deployment, and our use of Helm charts for deploying both the worker containers, but then also the services such as RabbitMQ and QGIS enables us to deploy all these interrelated resources and services using a single command. Helm also allows us to share global configuration values via value YAML files that Helm supports, so that we can use these value files to specify the gateway metadata server endpoints, for example. And the server endpoint is used by the worker containers to send metadata records that have been extracted from the geospatial files. Our use of Helm also allows us to provide rolling updates to the workers independent of the other containers that may have been deployed alongside these worker containers in our deployment. Finally, and more specifically for our case of geospatial data, our use of QGIS map server and the QGIS projects for managing map layers avoids the need for resource-intensive pre-processing that is required by some other map servers, for example, GeoServer. However, when you're using QGIS projects, there is essentially a single project file that manages all the map layers, and so updating a single file in response to file events is not thread safe, and this is particularly the case when you have several worker containers that may be operating on multiple geospatial files. To get around this, we use the Oslo concurrency library to make the code that is processing the geospatial files thread safe. The added advantage of using RabbitMQ as a message broker is that we can essentially requeue messages if the files are not really ready for processing at the moment, or if we run into errors or exceptions. And this is particularly required in the case of vector geospatial files, which are in the S3 shapefile format, because a single shapefile is actually a collection of 4 interrelated files. And all 4 files need to be present before either the metadata can be extracted or the file can be visualized. So while our last particular lesson was really specific to my GeoHub and geospatial files, we believe that our event-based file processing pipeline is something that can be easily generalized and deployed to any particular gateway that needs to process files in response to various create, update, or delete events, and also help separate the gateway framework from the file processing pipeline. I'd like to end by acknowledging the support of NSF that made this work possible, and also thank the HubZero and JetStream teams for their help with this deployment. The Helm charts for this deployment can be found in our project repository link here. Thank you.